okay? So group 1 is always +1. Group 2 is always +2. Group 3, let's take a look at our group 3 metals here. Oh, it's being sticky. It's thinking hard. Okay, group 3. What do you notice about all the charges of group 3? They're all 3+. So that's easy, yes? Group 3, group 1, 2, 3, it's +1, +2, +3. Okay? There is also a little staircase of elements that we will look at in a moment. Okay? However, the transition metals, the lanthanides, actinides, and the ones we called other metals can have more than one possible charge. So sodium is always +1. Barium is always +2. But if you have iron, iron can be +2 or it can be +3. Yes? So there needs to be a way of telling which version of iron, the iron ion you have. Do you have iron 2+ or do you have iron 3+? We are going to be recognizing these ones because on our periodic table, what you can see here is there is a dark gray area down here, and I'm just going to surround it by my red pen here. And you guys are actually going to color in for yourselves the red zone. So here's the deal. I managed to scrounge up 13 red pencil crayons, okay? Some of you have done this yesterday, so you don't need to do it. I also have a whole bunch. I thought I was ordering pencil crayons. I was not ordering pencil crayons. I was ordering like wax pencils that will write on like glass. But they will work. You just can't press too hard. If you press too hard, it will be like really ugly. But if you just press lightly, it should work just like a pencil crayon. Okay? So you're going to get one of these or one of those. Okay? Here we go. And you are going to, on your yellow periodic table, color in the red zone, which goes all the way to copper, and then there's that funky little staircase that doesn't get colored in. Okay? And then tin kind of shoots up there, and we have bismuth. The other part you're going to color in is the lanthanides and the actinides. So why don't you get your periodic table? If you don't have one, come and see me. I will get you one, and get yourself a pencil crayon of some kind or flavor or the other. Does anybody else need a periodic table? There we go. Thank you. Anyone else need a periodic table? Because if you aren't, you can color on one that's like not very already. Oh, yes. You good? Yeah. Okay, cool. Okay. So if you have finished coloring, in pencil, if you want to, you can put in the charges if you think you're not going to remember them. If you're planning on doing an enriched version of the test, you're going to want to memorize these. That group 1 is +1, group 2 is +2, and that group 3 is +3. You would also want to memorize that aluminum, gallium, and indium, of which there are 3 of them, are all +3. Zinc and cadmium, of which there are 2 of them, are +2. And silver, of which there is 1 of them, is +1. But if you're not doing the enriched, you can just write down those charges on your periodic table. No problem whatsoever. When I provide you one for the test, you'll just tell me which version of the periodic table you want. Okay? And the other ones you should know is that group 15, 16, 17 are all -2, or sorry, -1, -2, -3 as you go over from the halogens and work your way to the left. When you are done with your pencil crayon, if you wouldn't mind bringing it back, that'll also help me know if you're done. Thank you. Thank you. Yeah. So, all the ones that I've shaded yellow are monovalent. Now, if you would like to, I also have a fairly large chunk of blue pencil crayons that you could borrow. I don't have quite as many, but if you would like a blue pencil crayon to color the other ones blue, you can do that. If you want to highlight them, you can do that. Let's see if I have any more blue ones. Did anyone want a blue pencil crayon for those? If you do, they are right here. That doesn't look very blue, that looks gray. So the ones that I colored yellow, you could color in blue if you want to. You're not required to by any stretch. Actually, I guess I could color them blue and that would be even better, wouldn't it? There we go. Yeah. Yeah. And the reason that we're coloring them different colors is that we actually name them different ways. You've already done a whole bunch of compounds where we had like NaCl, right? Na is a monovalent metal. It only has one possible charge. Na is right here. We don't do anything with its name. We just call it sodium chloride, yes? But if you have something that is in that red zone, and there's a reason I had you color it red, because R is for red, and R is also for Roman numeral. So any metal that is in the red zone needs a Roman numeral in its name, and we'll figure out how to do that in a moment. Goodness. You can do something with the nonmetals if you want to, but I wouldn't bother. You can just leave them alone if you want to. I'll just give you guys a few minutes more to finish up on that. We are on page 15, Jack. Yes. Yeah. Yes. Non-metals are all monovalent, all of them. So multivalent only matters for metals, okay? Metalloids tend to bond in a covalent manner, which means they won't have charges. Yeah? How are we doing? Anyone need more time? All right. So as you can see here, this is page 16. Metals in the red zone will require a Roman numeral. Red zone starts with an R, Roman numeral starts with an R. It will tell you the charge of the multivalent metal. So if I have iron 2, that means that the charge is 2+. Yes? Very often students think that 2 means that you have 2 irons. That's not the case at all. It does not mean you have 2 iron atoms. It means that the charge of the iron is +2. So what would we write if we wanted to say iron with a charge of +3? Iron 3, yes? So we have a 3 and we have a 3. The Roman numeral does not tell you the number of each atom. Yes, you sure may. Now what you're going to have to do is from the formula, you are actually going to have to figure out what the charge is. Okay, and it's actually really straightforward math. Okay, so don't panic. You can choose to work along with this in the book. I'm actually going to write it out on a separate sheet of paper other than the first time. If you want other paper so you can write along with me, you might want to get some. So here are the steps to find the Roman numeral from the formula. Number 1, you're going to write out all the ions, correct number of each. How do you know how many ions of each type there are? Let's say I gave you a formula like Fe2S3. How many irons are there? 2. And how many sulfurs? 3. So you're going to use the subscripts to tell you. Okay? So when you write out all the ions, the correct number of each, you're going to use the subscripts to tell you the number. You're going to find the charge of the negative ion. The negative ion is easy because you only are going to have a 1, a 2, or a 3. So if I go back here and we look at our periodic table, if I was to give you nitrogen, what would its charge be? Nitrogen is -3. If I gave you fluorine, what would its charge be? 1-. What if I gave you sulfur? 2-. What if I gave you phosphorus? 3-. What if I gave you bromine? 1-. What if I gave you oxygen? 2-. You get the idea? Like, it's really easy to find the charge of the anion as long as you know it goes 1, 2, 3. And unless you're doing enriched, you can have those charges right on your periodic table. Okay? So we write out all our ions. We find the charge of the negative ion. Then we find the total negative charge just by adding them up. What do you know about the charge of a compound? Compounds are always neutral. So let's say that I had a total positive charge of 6. If I had +6, how much negative charge would I have to also have? I would have to have -6 to give me a neutral charge. Yes? So the total positive is always equal to the total negative. Finally, we spread out the total positive charge onto the cations, which might not make sense now, but when we do an example, it will make sense. And the charge on a single cation is the Roman numeral, okay? Because remember, the charge is the Roman numeral. So this first one, we will just follow along in here. We have Fe2. So how many Fe's should I write? 2. Okay, 1, 2. Is good so far? Okay. How many O's do I have? I have 3. So how many O's am I going to write? 3. Oh, shocking, yes? 1, 2, 3. Step number 2, find the charge of the negative ion. So go back to your periodic table and look up oxygen. Here is oxygen. It is in group 16. If you're in group 16, how many valence electrons do you have? You have 6. So how many electrons do you want to gain? 2. And so the charge of oxide will be negative 2. Or you can have the charge written on your table, okay? So then we go through and we write in the charge for oxide. We write it in on every oxide ion. So on each of the 3, we write in 2 minus. Then we add them all up to find the total negative charge. 2 negative, 2 negative, 2 negative equals 6 negative. Remember, the whole thing has to be neutral, so the total positive charge has to be positive 6. Okay? And now we look and we say, I have positive 6. What charge do each of the irons have to have in order to give me a positive 6 charge? I have 2 of them. They have to be 3 plus each, yes? 3 plus and 3 plus gives me positive 6. Okay? When you get good at this, can you do it in your head? Absolutely. When you are not good at this, should you be doing it in your head? No, because you will make errors. So you will notice that I've given you lots of space. We're going to try another one together. However, I'm going to go just to a blank piece of paper here because we are going to do the formula Cu3N2. So if you have a blank piece of paper and you want to write along with me, so you can follow the steps because that's often a good way of making it like work in your head, that would be a good idea. If you want to take a moment and grab a piece of blank paper, you can do so. What is step 1? Write out all the ions. So we're going to need 3 coppers and 2 nitrogens. So you write out Cu, Cu, Cu. Because there's 3. We are also going to write out all the N's. Okay, so I have N. How many N's do I have? 2. So I've written out all the ions. That was step 1. Step 2, what do I do? Find the charge of the negative ion. So you go back to your periodic table and you say, I need nitrogen. Nitrogen is group 15. How many valence electrons? Yeah, it's got 5 valence electrons, so how many does it need to be full? 3, so its charge is negative 3, or it's written there for you. So we write in 3 negative, 3 negative. We're going to add up those 2 3 negatives. What do we get as our total charge? 6 negative. After we figure out our negative charge, what do we have to do? We have to figure out, once we have the negative charge, we figure out the positive charge. How much positive charge? I have 6 negative and I need the compound to be neutral, therefore how much positive? 6 positive. How much charge does each copper need to give me 6 positive? 2. So now I've figured out that charge. Now what I'm going to do is I'm going to now say I have copper and it's in the red zone, so I need a Roman numeral. And then I have nitrogen, which is nitride. Tell your partner, am I going to put a Roman numeral 2 or am I going to put a Roman numeral 3 in those brackets? What does the Roman numeral represent? The charge. So which Roman numeral are we going to put in those brackets? We're going to put a 2. Okay, that 2 is that 2. We don't use that 3. It doesn't tell us how many. Do you guys want to try one yourself? And then we'll go over it together. How about this one? PbO2. Hopefully what you're doing is you're writing down that you have 1 Pb and you have 2 O's. Once you've got that, you find the charge on the O. What's the charge on oxygen? -2, good. What do we do next? Add up all the negatives and we get 4. Once we know the negative, what do we find? The positive. What does the positive have to be? 4 plus. These two always have to be the same, right? Just opposite signs. Okay? And now this one's really easy. Where's the only place I have to put all of that 4 plus charge? Right here. Yeah? So now I want to name this sucker. What is the name of Pb? Pb is lead. And lead is in the red zone. What does it need if it's in the red zone? If it's in the red zone, it needs a Roman numeral. So what do I put the Roman numeral in? I put it in a pair of brackets. And what do I write 4, which is IV. And then how do I write the name for the O, O2? Oxide. Okay? I don't put any Roman numeral after the second word. It's like a middle name. You know, it's like these ones need a middle name to tell you which iron it is, or lead, or whatever. We're going to do one final example because it will never get worse than this. This is as bad as it gets. Step number 1. Write out all the ions. Does everyone know how I got 3 manganese and 4 phosphorus? Yep, okay. How do I know what the charge of phosphorus is? Look on your periodic table. Phosphorus is right under nitrogen. It is group 15. Its charge is -3. And if you need these and you have not yet written on them on your periodic table, write them in for yourself. If you don't need them, then you don't have to write them, okay? Oh, what am I doing? I'm going back here. So this is 3 minus. Oh my goodness, I need to write it 4 times. Add it up. What do I get? 12 minus. What do I get on my left? 12 plus, because they have to be equal and opposite. Okay. How much does each manganese have to have? 4. So we're going to now name this, whoops, why does my M have so many bumps in it? That's crazy. Manganese for phosphide. Okie dokie. So this particular worksheet gives you lots of space to do it, but if you're finding that's not enough space, you can use extra paper, right? If you've got large writing or whatever and that's not enough space. So that would be page 19. Quiz number 4, however, is actually about whether you use Roman numerals or not. So before you do quiz 4, you'll want to do page 19, 20, and 21. Some of you have completed quiz 3 already. If you have, that's great. If you have not, so this would be the second thing that you do. The first thing that you would do is make sure you've completed page 13 and 14, and you do quiz 3. Quiz 3, remember, some of them are going to be ionic, but there's no Roman numerals. Okay, going backwards. Some of them are covalent, and you will use prefixes. And then for quiz 4, we're throwing in the Roman numerals. But quiz 3 has no Roman numerals. And if you're confused by anything, call me over and I can help you out. Some of those little flow charts at the front of your book might help you. Okay? Prefixes are always pronoun compounds. We don't use them for any noun compounds. Yes, come with me and I'll show you how to find them. Okay. I got some from the top. So if you want to go I watch the first group, so it's today, so go right behind there. Yes, this one is all prefixes. And then 3, semicolon, so 5 prefixes the second one. There you go. 8, hello. What will happen is that in order to do that, we can make a mixture, but it can be a compound because you have an actual set ratio between them. So water is always like 2H12, and that of sodium chloride is 1 to 1. When I take metals, instead of them combining that way, we just melt them. They all go together, we stir them up, so I can have like 90%, 75%. So we don't want to put it in the same like formulas for it. Because later on, I'm going to say you have magnesium chloride formula, and you'll need to know that this is +2, and that's -1. So when we go down Chris. Zion. See if you know what you did wrong. Let me know. Okay, if you have trouble figuring it out, ask me a question. Yes. So the only thing you got wrong was phosphide, not phosphoride. So anytime we have, anytime we change the ending to "ide", we usually have two syllables, so phosphide rather than phosphoride. Yeah? You are allowed to redo that if you want to. Yep. Jude. Seyoung. Very nice. Oh no! Okay, let me put that as a little boo-boo on here. So that's page 19, number 7. Okay. Well, it's page 19, number 7. The answer key is wrong, but it's pretty obviously wrong, so you can just skip it. Okay. Excellent. Okay. Thomas, your quiz is ready. Number 2. Yes.
I got what I did wrong for number 5. But okay. I don't get number 6 and number 1.
Okay. Sodium is not in the red zone, therefore it does not use a Roman numeral.
Oh,
okay. And for this one, you forgot to change the inside.
Oh, okay.
Yeah? Okay. Kaylin. There you go. Joshua. There you go. Okay. Does everyone have an answer to the report at this point? Yes.
This one's like all of them combined, right?
It is just, it's the only ionic ones. There's no covalent. But there will be some with Roman numerals and some not. Okay? Yeah. Dan. Hi. Hi. There you go. Okay, so we are going to take our break, but if you're in the middle of writing a quiz, you can finish that up and then you can start your break 5 minutes later, okay? Thomas. Oh yeah. Ida. That better? A metalloid is considered a non-metal, okay. Yes. Yeah. Chris. Oh, he's not here. Okay, that's easy. I'll give it back to him afterwards. Alvin. There you go. Sion. There you go. While we do that, I'm going to give you that. This one. Yes. And one last one. No couples in the middle of the